Okay, hi everyone. Welcome back to this video series Introduction to Firewalls, thin client solutions. Many companies look to thin client solutions to allow full network access to users who don't have full computers or less powerful computers. Rather than requiring high processing power at the client level, a thin client solution performs all processing at the terminal server. Two standards have evolved for thin client solutions: Citrix Metaframe and Microsoft Windows Terminal Services. Although they use different protocols, both thin client solutions enable clients to connect to a central terminal server, allow administrators to take remote control of thin client sessions, and give administrators the tools to remotely manage servers. Microsoft Windows Terminal Services is the same suite of protocols now referred to as Remote Desktop in Windows XP and Windows Server 2003. Citrix Metaframe. Citrix Metaframe makes use of the Independent Computing Architecture (ICA) protocol to allow thin clients to connect to a Citrix terminal server and execute applications by using the processor power of the terminal server. Citrix allows connectivity by using either native ICA clients or web-based embedded applications. Citrix supports Java, ActiveX, and Netscape plugins for embedded clients. Many companies are moving toward embedded clients to reduce the costs associated with distributing the client software to all client computers that require access to the Citrix Metaframe server. Table 713 shows the firewall rules that must be included at the firewall to allow access to a Citrix Metaframe terminal server at IP address 172.16.1.205 on the internal network. So protocol ICA, transport protocol TCP, source IP ANI, source port ANI, target IP 172.16.1.205, target port 1494, action allow. This set of firewall rules allows only external access to an internal Citrix Metaframe server. If you require internal clients to connect to Citrix Metaframe servers on the internet, you then need to apply firewall rules shown in table 714 at your external firewall. So protocol ICA, transport protocol TCP, source port 172.16.1.0/24, source port ANI, target IP ANI, target port 1494, action allow. Windows Terminal Services. Starting with Windows NT 4.0, Microsoft released its own version of terminal services based on the Remote Desktop Protocol (RDP) with the release of Windows 2000. Additional features such as remote control for non-console clients were included to create parity with the Citrix Metaframe offering. The Internet Assigned Numbers Authority refers to RDP as the Windows-based Terminal (WBT) protocol. Both names reference the protocol discussed here. Table 715 shows the firewall rules that are required to provide access to a Windows terminal server located at IP address 172.16.1.204 on the internal network. So RDP, TCP, ANI 172.16.1.204, 3389 allow. Likewise, if access is required to the internet-based Windows terminal services, the firewall rules shown in table 716 must be implemented to allow outbound connections to the terminal services. So RDP, TCP 172.16.1.0/24, ANI 3389 allow. Internet Control Message Protocol, ICMP. In addition to the protocols already discussed, you must create firewall rules for the ICMP protocol. When you learn TCP/IP, one of the first commands that you are taught is the ping command. Ping is the command that uses the ICMP protocol to determine whether a host is reachable on the network. When you send a ping packet to another computer, that computer responds with an ICMP response packet that indicates that it is reachable. The problem with this protocol on the internet is that many attacks start by identifying whether a host exists. If your internet accessible computers respond to ping packets, an attacker may create a complete map of your internal network and follow that with a port scan to determine what services are available on your server. This could then be followed by an attack against your computers. To prevent this scenario from occurring, you can configure your firewall to allow only specific ICMP packets to pass through the firewall while blocking the ICMP packets that can reveal the existence of your network on the internet. Before we show you the firewall rule that needs to be deployed at your firewall, look at the various messages that can be transmitted in an ICMP packet. ICMP indicates the purpose of a packet by setting the packet type to one of the following: echo request. The host initiating the ping request uses this type. Echo reply. This type is used for the response packets to a ping request. Redirect. A router uses this message type when the packet should be transmitted through a different router that is closer to the ultimate destination of the ping packet. Time exceeded. A router uses this type when time to live TTL for a packet reaches 0, causing the packet to be discarded. Parameter problem. If a router finds errors in the format of a ping packet, the packet must be dropped, and the parameter type is used to indicate why the packet was dropped unreachable. If a router can't route a ping ICMP packet to the destination, the unreachable type is used. Source quench. If packets arrive too quickly for a router to forward the packets must be dropped. In this case, a ping ICMP packet is sent to the originating computer with the source quench as the type. So I'm only here this evening for this video. Next, I'll be moving on to chapter 8. So thanks for listening, and please share and subscribe. Thank you.